Hi everyone, welcome to my channel Tech World with Prerna. So today I'll be discussing about solid design principles. But before starting the topic, let's discuss why these principles are needed. So design principles are a set of guidelines or best practices accumulated over the years which make your code more scalable. When you apply these design principles, you end up with a code which is more testable, readable, and understandable. The structure that these principles provide to our application make our code easy to maintain. And when your code is easy to understand and easy to maintain, then it makes a collaborate to work on it. So five different types of design principles makes a solid design principles. The acronym SOLID is made up of the names of five design principles that focus on improved code design, maintainability, and extendability. Without using a good design principles, your application may become rigid, fragile, and immobile. So it is always very much needed to accommodate the design principle from the starting of your code implementation. The first design principle is single responsibility principle, which says that one class should have one responsibility. So basically it says that do not try to do much in same class or method. The second design principle is open or closed principle. It says that the class should be open for extension but closed for modification. So you should be able to extend rather than modify an existing class to add or change functionality. Third design principle is LSP Substitution Principle, which says that the subclass should be substitutable for their base class. So if A is a subtype of B, then B objects in a program can be substituted with A object without affecting any of the program's desired qualities. Fourth design principle is interface segregation principle, which says that the many client specific interfaces are better than one general purpose interface, which is like the interfaces should be split down into small groups or related members that are implemented by all classes that implement the interfaces. So this design principle very much implies to the single responsibility principle. And the last one is dependency inversion principle. DIP states that the class should depend upon the abstractions and it should never be depend upon the concretions. Let's discuss single responsibility principle. This principle says that one class should have one responsibility, as the name clearly states. So basically, do not try to do much in the same class or method. This notion is broken if you implement reading from a text file, writing to a database, making a service call, and writing to a log all in the same procedure. Here we will take one example and we'll see that this class how it is violating the single responsibility principle. And after this we will see that how we can refactor into the single responsibility principle. Here the developers have written a class called customer multi-response. This class is having the two instance variable, name of type string and balance of type float. So here you can see that developers has violated the single responsibility feature. Sorry, principle. What is evident here is that the single class is responsible for the customer information and the transactions of the bank account. So clearly it is visible here that developers has messed up with the single responsibility principle. So let's see how it can be done after applying single responsibility principle to the customer at bank example. So here We can segregate it into two different classes, and the one class will have the name instance variable with the customer detail information, and the second class will have the account number and balance which is related to the bank account, and customer will have the account instance as a constructor, and it can fetch all the information of the account, whatever it is needed from the another class which is playing the responsibility of dealing with all the account informations. Open closed principle. So OCP states that classes should be open for extension but closed for modification. So you should be able to extend rather than modify an existing class to add or change the functionality. That is, inherit from the class in a subclass that extends the behavior of the superclass with new functionality. So this principle simply states that if you want to perform additional functions, then the best approach is to add to the existing functions rather than changing them. Let's take a look of this principle. Here we will look into the example which will strengthen our understanding of open closed principle. So we'll see that first how this open closed principle is violated and how we can refactor it, and then make it tuned to this principle and make the application work. So here we'll see the example of food order application, which is having a class main course items, and it has extended the abstract class menu item, which is this menu item is having an instance variable of price, and the abstract method of prepare, and there is menu item method. So here in this food order application, so it is taking all the menu item from the customer, and then it is processing the order, and then it is publishing the final bill. So here with this application, there could be a one problem that if the customer is ordering for the dessert item, then the dessert item you don't have to prepare the food. The dessert is just a prepared food, and you just have to freeze it. But for that you'll have to do the change in the food order class, and then based on the instance you'll have to change the price, and then you'll have to process it. So we'll see how we can solve this, and without violating the principle, how it can get solved. So after applying OCP to food ordering example, here we'll see that food order class will just add all the menu item which is ordered by the customer, and it will process the order and it will publish the final bill. Menu item is the abstract class here, which will be extended by the dessert class and main course class. And course class will just have to prepare the food. So it will prepare it, and it will publish it that what is the price of that. And dessert class will have the bake method, that is the additional one, and it will bake the dessert item, and then it will publish its price. The food ordering class will just call add all the menus in the class, and it will publish it the final bill. So here, without violating any OCP principle, the entire application can work fine. Even if any soup or beverages needs to be added, it can be added, and it can extend the menu item as a abstract class, and then food ordering class will just add those using the add menu item, and it can publish the final bill. So this using this OCP principle, so here we are seeing that how you can just extend the class, and without changing the functionality of the class, you can take all the requirements whatever it is coming to the application, and you can solve it without changing your main or parent classes. LSP Substitution Principle. So this principle states that subclasses should be substitutable for their base classes. which means that the child class should be able to process the same requests as the parent class and deliver the same result or a result of the same type. Let's look into this zoo application example to strengthen the understanding of LSCO substitution principle. So here in this zoo application class, there is animal class which is having the eat grass method, and horse class has inherited the animal class and it has overridden the eat grass method of animal class. Now in zoo application we have another type of animal which is lion. So lion class will also inherit animal class, but lion cannot eat grass, so it will throw exception saying I don't eat grass. So, since a lion class, which is the derived class of animal, it cannot override the eat grass method of animal, then it is violating the principle of Liskov substitution principle. Now, let's refactor the code, and after applying LSP to this zoo application, let's see that how we can solve this problem. So here in this application, animal is the abstract class which is having eat method as abstract method, and they are carnivorous and herbivorous two classes. So these two classes are also the abstract classes which is extending the animal class, and it is having eat and eat methods. So the carnivorous will have eat and eat meat, and herbivore class is having eat and eat grass method. So both are also abstract classes which is getting extended by the lion and the horse classes. So lion, since it is a carnivore animal, so it will implement the eat meat method, and horse which eats grass, it will implement or override it will override the eat grass and eat method of herbivore. So in this way we can solve this problem, whatever we have seen that before applying LSP or which was violating the LSP principle. So here we could see that whatever the derived class is having, it can easily get substituted, and it has all the functionality and the features of their parent class or the superclass. Interface segregation principle. Interface segregation principle state that many client specific interfaces are better than one general purpose interface. Interfaces should be split down into small groups of related members that are implemented by all classes that implement the interface. Basically, it states that the client should not be forced to implement the method which it will not use. Let's look into the example of coffee shop application which will strengthen our understanding of interface segregation principle. Here there is coffee class which is having a price as a instance variable which is of type double, and there is add milk, add coffee, and coffee as a constructor. So this coffee class is representing all the types of coffee which is getting ordered in the coffee shop. So here in this coffee shop application, there is a latte and espresso class which is extending or inheriting a coffee class. So latte is calling the super constructor and then overriding all the methods of coffee, and espresso as well. But latte as a coffee, it will have extra milk and extra coffee, so it will work fine. But espresso will never know how to override add milk and what to do with it, because espresso coffee will not have any milk component in that. So then it will throw a exception, and it will violate the principle of interface segregation principle, which says that you cannot force your client to implement the method which it is not using. So now we will refactor it, and after applying ISP we'll see how we can solve this problem. So after applying ISP, Here we'll see that we are having one interface coffee which is having price as a instance variable, and add coffee is the another method which is getting implemented by latte and espresso, and the milk based coffee is another interface which is having add milk as a method. So whatever the coffee which ideally it should be without milk or with milk. So any coffee which needs to be prepared with milk, they can implement this milk based interface, and the coffee which it is not needed, can directly uh, it can directly skip that. So here you can see with applying the ISP principle, we can easily achieve the non-milk based coffee and the milk based coffee, and it will not violate the principle, and you can easily run this code by using this principle. Dependency inversion principle, DIP, states that depend upon abstractions and do not depend upon concretions. In other words, when we are working with the entities of different layers, then all the entities should be bound together with the abstractions. Let's take an example of robot application to strengthen our understanding of a dependency inversion principle. Here we'll see that how this application is violating the principle of diversion inversion, and then later we will refactor it and we'll see that how we have solved it. Here in robot application we are having two classes, one is walking bot and another one is talking bot. So walking bot is having a walking method and talking bot is having a talking method. So here when I'll have to club it with the bot demo application, then I will just instantiate this walking bot object, and the second one is the talking bot object, and with that I can show that what these two bot is doing. But here it is violating the principle of dependency inversion, because both the classes are working separately and both the classes are showing their features separately, which you can combine in combining in another classes to show their behavior, which exactly not what DIP states. So we'll see that how here we are solving it after refactoring it. So here we will have a bot interface which will have a perform method, and will have a talking bot and walking bot as a class which will implement perform and the talk method. The walking bot will implement walk and perform method. And in the bot demo class, you can directly take the list of all bots which is of the type talking bot and walking bot, and any additional one which will come later based on your future requirement, and then you can display all the functionality where these bots are doing, which is the ideal way to run any application. So you can see that here by implying the DIP principle, how this exactly this application should run. Thank you.